Cool. Alright, solving cubic inequalities and find a rule for unknown cubics. Given some info. Brilliant. Alright. So, first thing I've put up there has absolutely nothing to do with this, evidently. But we're going to use this to springboard into others. So, okay, I've got this thing. What does this thing look like?
Straight line.
Straight line. Where does it go?
Bottom from bottom to
Okay, does it go through anywhere in particular?
Y 4.
Goes through y equals 4, okay. Oh, sorry, it's in 0.04, yep. And, right, negative 2 on the x, cool. Get something like that. So 4, sub negative 2, 0. Brilliant, okay, boring, easy. Okay. Let's do the following. Let's say y is less than this. Okay, what's that talking about then? Right, anywhere below that line, yeah? Cool, because y, the lower down you go, the lesser it's getting now.
And you make that line dotted.
Right, and we would make this line dotted or dashed.
Yeah.
Alright, so we have that, and then this bit, this bit, this bit, this bit, they're all good. Cool, unsurprisingly, we go the other way around, what happens? Everything on the other side becomes okay. Dotted line across here. That's okay, that's okay, that's okay. Brilliant, easy, boring. Cool, alright. Got, what's this? Quadratic, so what's it look like? Right, parabola, smiley face. Cool. Anywhere in particular?
Negative 6 and negative 2.
Cool. Factorizing is your friend. Cool, so we're at negative 2, 0. Negative 6, 0. Something like that. 0, 12. Great. Okay. Same as before. If this was a less than, what are we doing?
Oh, okay.
Everything below it. So here, 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 here. Cool. And vice versa. Everything above. This bit and this bit, yep. Cool. I'll say yeah, that's fine. Yeah, that's good. That's fine. Okay. If I wanted to, okay. We're going to do the same thing with this, right? We're going to greater than less than eventually. Cool. What is it? Cubic. Okay. What's the first thing you're going to do?
Try and find a common factor.
Right. Common factor?
Oh, sorry, well,
You're going to try and factorize it. Yes. Common factor means like you're just taking out something.
Yeah.
Yep. So, yeah, you're going to try and factorize it. Okay.
Negative 2.
Ready, set, go.
Done.
Oh, you've already done it? Okay.
No, we've already done it.
Okay.
We've used it before.
Oh, have I?
Yeah.
Oh.
I just looked back in the book.
So much for imagination. No. Is everyone happy that they know how to do this?
Yeah.
Okay, do it.
Oh.
That's it. Oh, that's why I can't roll. We're still going, or we're done? We're still going. Okay. Oh, we're still going? Okay. That is like, that works, right? I didn't stuff up anything. That was done. Yes, yes. Yes, yes. Nice and imaginative. All good? Yep, okay. So, we all ended up with that, right? Yep, cool. Unimaginative. There you go. Go, oh, what can I draw for this thing? X-intercepts of? Beautiful. Cool. Neg 2, neg 3, neg 4, so. 0, neg 4, cool. Okay. Plane connect the dots, what does it look like? A wave, okay, which way? Alright, start at the bottom left. Go through. Ooh, well, it's a bit bad, but you get the idea. Cool, something like that. Cool, alright, do we know what this is? 24, we get that for free right at the start. Fantastic. Alright. Cool, if we go less than, anywhere below, go greater than, anywhere above this. Cool, beautiful, easy, boring, done. Alright, so that's 6G is really short. There's only 2 questions in there, like 2 sets of questions. It's pretty short, pretty straightforward. Yep.
Shouldn't it say -4 and -3 instead of -4 so -3?
Oh, yeah,
no line was this long.
Just that 4 over there as well. Thank you. Thank you.
That's on the last one.
Yeah, it's on the last one, just last year.
That's that's why they get you to write them.
And on the
because
first,
you can
first
show
one that you just drew, like the first, the one we haven't started, the ones we haven't started, the first one.
That's 0, -1.
Oh, well.
2, 3.
Okay.
So that's
I got
actually
confused by that. I got confused by
Yeah,
that.
these two are, they're all correct now, yeah?
I think so.
Beautiful. Alright, so that's stuff from there back. That's 6G. Pretty straightforward. You just treat it as though it's equals, and then afterwards you go, okay, now I'll treat it as an inequality. You go nuts from there. Cool. Alright. This is actually where the meat of this day will come in. I have given you a cubic. What can you see from my masterful presentation?
That the x-intercept and y-intercepts are right.
The what?
They're not labelled correctly.
I haven't labelled an x-intercept.
Oh, facts.
That the y-intercept is negative.
That is
Okay, y-intercept is -1. Cool. And
There are no x-intercepts.
there is an x-intercept.
Label as it.
You could probably figure out a way to but I don't know.
Thank you. Point of inflection is 2, 3. Cool. Okay. Let's see how much we remember. If it looks like that, what kind of form does the rule have? What do we got? Open bracket. Minus h usually, yeah. Q. Plus k. Right. It's the nicest one you can get usually. Fantastic, okay, great. What can I do with that? Sub stuff in, what stuff? Right, h and k we know. As well as y. Dial back a second. What do h and k represent? Point of inflection, right? Sweet, we've got the point of inflection. So therefore, y must equal something like that. Beautiful. Okay, how many unknowns do we have left?
2.
Count again.
3.
Okay. Yes and no.
Y and
When you get a complete rule for a cubic, what things should still be in there? X and Y should still be in there. So how many actual things? Right, there's just one missing. Yeah. Okay, how can we get it?
subbing x and 1.
Sub what in?
Not 2 and 3.
If I sub 2 and 3, okay, let's sub 2 and 3 and just for giggles
Why
then.
wouldn't you have to sub 0, -1?
Right. Let's sub this in just for giggles.
Just 50.
Okay, 2 minus 2 is? Cube it.
0.
0 times A.
0.
Okay, 3 equals 3. Yep, it's true. What was that helpful? Right. Why did that happen? Right, we already used that to get this. We've already exhausted all the useful information of it. So when you try to use it again, it just goes, sure. I mean, it's consistent, but you don't know what it is. So that's already been exhausted. What's the only piece of information we haven't used?
0, -1.
Right, 0, -1. So let's sub him in. What was it? 0, 0 minus 2, 3, okay. And then?
And 0 minus 2 cubed is -8.
Right, so I've got A by -8 plus 3.
So minus 3, which is -4, and divided by -8, which is -half.
Is what?
Negative. Oh, sorry, positive half.
There you go. How do you know that it shouldn't have been negative?
Because it's a negative divided by negative.
Because the.
I see.
Right, the graph goes up. So straight away, you know, if you had a bent double tank and you write it out,
Yeah,
you
no.
look back at your graph. This is why you always look back and double check to make sure that it makes sense. Because it's easy to do stuff like that, drop a negative halfway through. Cool. So, therefore, y equals, or f of x equals, depending on how it's written, half x minus h cubed, not h, what do we have? 2 plus 3. Too fond of that button. What's this? That's a bit better. Ooh, that's much better. Minus 2 cubed plus, oh, there we go. Cool. Future reference, if it asks you for the rule and you stop there, you are losing a mark. you haven't actually stated a rule. So whenever you think you're done, 1, check that it looks right, and 2, reread the question, make sure you actually put it in the form that it wanted. Fantastic. Next guy. What kind of graph does it look like? Cubic, right? Big surprise, given what we've just been doing. But later on, you're just going to get all sorts of random assortments of graphs, so we've got to know what things look like. Cool, looks like a cubic, so we'll run on the assumption that it's a cubic. Okay. What form is this rule, or at least what form would be useful to take?
Here's A, bracket, X plus B, close bracket.
Right, so individual factors.
Yeah,
Why do you want that? It's good, but why do you want it?
because there's a lot of intercepts there.
Right, there's a lot of intercepts for free. Cool. So, what am I going to call this? Let's make up some. There we go. Great. What can I chuck in for free?
X intercepts.
Right, all these intercepts for free. Sweet. So I get x plus 3, x plus 1, x minus 2. Happy days. Cool. What do you want to do from there?
So I find A.
Right, we want to find A. How are you going to get it?
0, negative.
Right, sub in the most useful thing. Cool, so we can 0. No, you don't actually have to write the whole bloody thing out. If you want to save time, you are more than welcome to. Cool. How many A's have we got? 6, cool. Therefore, A is positive third. Cool. Does that look about right? Yeah, positive, going the right way. Cool. Let's go with that. This is a particular, that's a reasonably small number, so you're not expecting A to be really big. You're expecting it to be on the smaller side. It's definitely on the smaller side. Cool. Therefore, y equals 1/3 x plus 3, x plus 1, x minus 2. Beautiful. Cool. Next boyo. What's he doing? Yeah, you got 2x intercepts.
So one of them must be cubed, right? And then
One of them must be squared, right?
Sorry.
Which one's going to be the squared one? The negative 4, why?
Because it's bouncing.
Right, as soon as it bounces, you know that you're going to get a repeated factor. So a squared factor, or otherwise going to get higher up. Cool. So we've got one of them has to be, squared, the other one just sits pretty. Great. Don't know what A is. We decided that this was the -4, that ends up being +4. X minus 3, brilliant. Cool, what you going to do from there? Stop in your last one. A, well, 0 plus 4 squared, 0 minus 3. How many A's did we get? How many get?
Negative 42. 48.
48. Jeez.
Right.
Go. Therefore, A is. Timetables, rather handy. Oh, therefore, y equals order, whatever we have, x plus 4 squared, x minus 3. Beautiful. Happy days. It's all said and done. Instantaneously goes flat and then goes up again. Cool. Yeah, that's it. So that's all 6. What is that? There is one other type, which I'll just draw because I can't be bothered figuring one out. Might give you that point, that point, that point, and that point. Oh, actually, there you go. Let's not. right? Is that sufficient information to tell me what the rule is? Right? Okay, let's say I give you that point. Is that sufficient?
No.
Okay, I'm going to keep going until you have sufficient information. How many do you need?
2?
4.
Oh, in this case,
4.
3.
Okay, let's give you 3. Okay, what's your rule going to be?
3 steps.
No. I'm giving you 3. You just ask for 3. There's 3. What rule are you going to use? Right. You have no reason to preference any of these, so just write a super general one. There you go. That's some cubic. Right, you could pick the other ones, except don't pick that. It's going to make your life really difficult. And could fiddle around a bit with this, but not really. So you could either do this guy or this guy, but since you know that you're not going to have intercepts, this isn't actually overly useful. So just go straight to the expanded one, because then you don't have to worry about expanding anything else later. Cool. All right. How many unknowns? How many points do you have?
3.
Is that sufficient? No. What do you need? Right. You need 4 points. Right. Why?
Because you need to make every other value simultaneous.
Right. For every unknown, you need a piece of information. Back here, how many pieces of information? Oh, actually, sorry. Before I ask that one, let's go back. For this one, how many pieces of information were you given?
4.
4. So that makes sense. How many pieces of information were you given here?
3.
You're given 4. It's just
Oh,
subtle.
yeah.
So you've got 3 points. What's the 4th bit of information?
Negative 4 bounces.
Right, the fact that this bounces on the axis. So that tells you that you've actually got a square factor. So that's your 4th piece of information. You will always have 4 pieces of information required. Cool. If we go back to this, how many obvious pieces of information do you have?
3.
2. You've got 2 points, right? And then the 3rd part is what?
Doesn't make one intercept.
There's only 1 intercept.
The H and K.
That doesn't actually, no. Not necessarily, depending on what you do with that.
The fact
So
that
the fact
you
that
have
it
the
goes flat and different.
Right, the fact that you've got a point of inflection, right? The fact that there is a point of inflection is 1, right? Sorry, a stationary point of inflection to be specific, but we don't care about difference just yet, because you'll only deal with those for a while. And then the other part is where that stationary point of inflection is. So it's a subtle, but this one bit holds 3 bits of information, even though it's not obvious.
Why 3? What are they?
So the first one is the actual point, the number.
Yeah.
The second one is that it is a stationary point of inflection.
Okay.
Right, and what was the third? Oh, I forgot already. That it is a stationary point of inflection.
Doesn't the fact
Oh, sorry, that it's a point of inflection and that it's a stationary point of inflection.
And then the numbers.
And then, yeah, the last point down there as well. So 2 for the just numbery parts, 1 for inflection, 1 for stationary inflection. So yeah.
How do we know if it's not stationary?
For you guys, it always will be for now. Sorry? Moving isn't, it's calculus stuff. When we get into calculus, then we'll start to fiddle
They
with
do
it.
not remain stationary.
Sorry.
They do not remain stationary.
I mean, it's a static picture, so it's stationary, but that's not what it's being used to describe. We'll get there. Cool. So yeah, sometimes I'll just give you 4 random points, and then it's just a matter of, all right, plug them in. If you've got 4 random points, are you going to enjoy that process? No? Why not? Right, how many simultaneous equations are going to spit out? 4. You'll have a 4 system. Right? So 2 system, easy peasy, boring. 3 system, mildly annoying. 4 system, irritating. Alright, very easy to make errors. So particularly when you get into 3s and 4s, you want to start picking your pairings intelligently. 2, you've only got 2 to work with, so it doesn't matter what you do basically. 3s, commonly you can speed up with intelligent pairing. 4s, you can almost always either make a mess of it or make it quick, depending on what you start with. But I'll leave that to you guys to do it the hard way and then realise, oh, hang on, this is this. But then that would mean, oh, I could have done that a lot quicker. Flip a table that you'll learn something. The best way to learn that stuff is when you do it the slow way and then get irritated. And so you remember being irritated and you're like, hang on, this seems familiar, maybe I can use this fast way. Well, that's it for today. Good. Questions, queries, comments?